All right. Thank you, everybody, for joining. Thank you, LightWerks, for the opportunity to present. So I will be speaking about projected images and AI. I'm the senior product manager at Epson America for the large venue projectors. All right. So I'm going to touch on a few things, engaging your audience with large displays, and then talk about AI and machine learning for projection mapping. And then we'll talk about 3D model creation with photos and LiDAR, as well as AI image generation for content. And then toward the end, I will talk about specific Epson products and related to projection mapping and immersive experiences. All right, so engaging your audience with large displays. So as you're very much aware, everyone is inundated with screens, right? We have our phones. We travel, we go to the mall, we see large screens, digital signage. Outdoors, we see digital billboards. So there's a lot of screens everywhere, a lot of displays. And it takes extra effort to kind of break out from this excessive displays that we run into in our lives. And so there's an expectation for larger and more engaging experiences to really get any audience's attention, whether it's a student in a classroom or someone that's in a retail space. And so we're beginning to see across all verticals these larger or immersive displays. Let's call them that. So, for example, in education, you're having hybrid classrooms where you might have the students that are in the class as well as those who are remote, and as well, and you'll have like a super large screen behind the presenter and maybe even another large screen so that the teacher can see what they're presenting. In theater, you're seeing digital backdrops behind the stage performances. You're seeing projection on, basketball floor, stadium floors. In corporate and healthcare, there's visitor centers that use a lot of displays, hybrid rooms, of course, Teams rooms, a lot of corporate lobby experiences, and interactive and engaging signage. And of course, experiential, right? Museum, digital art, exhibitions, immersive art installations, or what have you. So here's kind of a look at some of these large or engaging displays. Architectural projection here, you project onto the outside of a building. Uh, Large art installations, interactive art installations. This is by TeamLab. They've got installations worldwide. This one's actually in Tokyo, Japan. Huge spaces that are being projected on to create these amazing art and interactive experiences. Many of you have seen or heard of the Klimt and the Van Gogh immersive spaces here in the US. And also you're seeing a lot of people take just large spaces and try to do something different with them. This is Temple House in Miami, a large white space with projection. You can turn it into anything. And of course, things at a smaller scale. You have galleries now. They have artists that come in with ideas for display digital art here on the left and toward the right. In churches displaying, for example, the ceiling. And of course, corporate environments, lobbies, you have large displays as well to kind of engage people or beautify the entrance or create digital signage. So all of these displays that we looked at are based on projection technology, and they're all larger displays, and they're on various type of media. They could be on a screen, on a wall, or an object. And projection from the very start has been the key benefit has been the easy way it creates large image sizes, right? And the ability, it's very flexible. The product itself is fairly large compared to the scale of the image that it projects. Also now with laser light sources, lower maintenance, and it's just a cost-effective way to create a large image. And over just the last 6 years, there really has been tremendous change, uh, technological change within projection. And projection's been around a long time, but the last 6 years have been uh, incredible amount of new technology has been produced by Epson and other projector manufacturers. A lot of this is driven by the fact that the light source has gone from being um, a lamp or xenon lamp to a laser. So a laser light source of phosphor creates that white light, has really created a lot of technological change, and especially now that we're in our second or third generation of laser projection. So the projectors have gotten incredibly small. Um, just speaking for Epson, we've had from one generation to another close to a 50% drop in the size of the projector and the weight. So as well as uh, prices in general for the amount of brightness you're getting is a lot better. Their projectors are brighter and hold a much better image quality from the lamp years. Okay, so let's talk about AI and machine learning for projection mapping. So a lot of the images that we saw earlier, example images, they are considered projection mapped images because they're not on a flat surface. So projection mapping is a technique that turns objects, any object, into a display surface for video projection. So these could be something of large scale, the outside of a building, the backdrop, or pieces in a theatrical stage, or smaller 3D objects. It could be a statue, it could be a car, anything that you want to project on that doesn't have a typical flat space face. So using dedicated software, the object is mapped, as you can see here on the right. This is kind of a test image as they've mapped a bunch of large columns and a balcony. And then the content within this special software warps the image. So um, the image is actually stretched and bent when it's sent to the projector. And when the projector sends it out, everything does not, nothing appears distorted because it has countered the effect of distortion of the three-dimensional object. So here's a good look. This is a building in downtown Columbus, Indiana. And here you can see how the different sections of the building have been projected on. You've got the top part getting a yellow picture, and you've got different content video playing within the window on the first floor. So there are key items in the projecting mapping process. One typically is to create a model of what you're projecting on. So you can create a you need to scan in that model and bring it into the mapping software ideally so you can figure out how to project on it. And then obviously the projection mapping software, there's a lot out there right now. They're getting more and more powerful, and the pricing is quite good. You can get some really amazing apps for very little cost for both PC and Mac. And then, of course, you have to create or design the content that's going to be projected on and set up the projectors. Where do you place the projectors? If they're outdoors, is there kind of environmental cages to put them in for protection? So these are the four key ones. So I'm going to dive into the creating the model, scanning or finding that three-dimensional model and how that relates to AI, and also about how to create custom content and how AI is improving. We'll also touch on ways manufacturers like Epson are improving and simplifying the setup of the projectors. All right, so 3D model creation with photos and LiDAR. So if we zoom in back to that model, that building in downtown Columbus, Indiana, you can see the intricate detailing going on in terms of the content. And that requires a very detailed model. So you can see here, everything has to be lined out so that the software understands the surfaces so it can properly take your content and warp it for the projection. And so the better your model and the details, the more you can do and the more realistic the projection is onto the building or the object, and the more exciting and the more detail you can add to it. Obviously, this is highly time-consuming work. So one of the processes used is called photogrammetry. It's, as the word says, it's a bunch of photographs, as you can see here and the bottom part of the screen grab. You take a bunch of photographs of the object. Here we're looking at a building. And then specialized software takes all these photos and attempts to create one three-dimensional object. And then that three-dimensional object can be entered into your mapping software. And then from there, you kind of line up what you need to do, and then you overlay the content. So it's definitely a popular way of doing it, but not without a lot of hiccups and issues. So you might get the model, but it requires a lot of work and cleanup. So here, for example, I've zoomed into a certain section, and you can see that's in the area in the center supposed to be balconies. And obviously, it doesn't look like balconies. It's kind of mangled. But what we're beginning to see is that machine learning, which is an application of artificial intelligence, where the app starts to learn as it does more and more work on the content. With this, what starts to happen is that the app starts to be able to figure out what it's seeing. So, for example, it'll begin to say, okay, I'm seeing windows, or that's actually a balcony. And so it'll start to fill in that and not get confused about what it's building, or also be able to help the end user, remove what's not needed. For example, you may be using photogrammetry to map out the inside of a large hall, and there might be I don't know, a column that you don't really care for, or a couple of boxes on the floor. So with machine learning, these apps are being able to kind of ignore some of these items and just concentrate on giving you the key image, which is the main walls of that hall. So this is kind of an extreme example, but for example, so this is an example of a castle in Japan. And if you want to map onto that, it's obviously very difficult. And there's a moat around the castle, right? So going around with your iPhone camera and doing photogrammetry is not easy. So some of the creative ways being done now, for example, is using multiple drones to fly around the castle and to create multiple pictures, and then finally create one high resolution model of the castle, which can be then utilized just for modeling use or for projection mapping. So once you've got the model into your mapping software, then it's all about your content and projecting on to the castle. As you can see here, this is Matsumoto Castle in Matsumoto, Japan. I was talking about photogrammetry, but also LiDAR is another way of doing it. LiDAR uses laser pulses to figure out distances. And it's also highly accurate. It's actually probably more accurate, definitely more accurate than photogrammetry. It's just, it's a more cumbersome, more costly device to use. But it'll also benefit from many of the items that we talked about when talking about photogrammetry. All right, so next topic is AI and image generation for content. So some of these examples of architectural projection or object projection, you can see there's a ton of content to look at. But all of it's all custom, right? So how do you once you've figured out the creating the model, importing the model, all of that cumbersome part, once AI makes that easier, there's still the issue of creating custom content, right? Because even more simple signage, it's usually at a very different aspect ratio of which most content is produced. For example, this one here, it's a signage application. You can just see how wide it is. And if you wanted to create some kind of video for it, you can't just go out and find pre-produced video at such a wide, super wide aspect ratio. So finding content is a challenge. It's because most content, as we know, is 16:9 or 16:10. That's kind of the format you see here, and some of the format you'll see when you're watching movies and TV shows. So it's all in this. And even if you find amazing content, it's still not going to be at the aspect ratio that you need. So that's where AI can come in and help. We're still kind of in the early stages of this, but I'm sure some of you have kind of played around with AI image generation, right? So this was something with Microsoft Copilot, and I typed generate an image of a cow getting abducted by UFO in the Midwest, and this is what I got. So you can play with it quite a bit, but there are already applications to utilize AI generation for many different things that have more practical, very practical uses. Um, so if we take a look at this and apply it to object mapping, what can we do, right? So there are certain steps now where you can use AI generated imagery. So this is a very simplified kind of step of how it would be done. So you would, from the angle of view that you want to project onto that object, you would take a picture and then you would upload that picture. So in this example, we want to project onto a white racing helmet. And then you would import this photo to a specialized AI image generation tool. And then you would set parameters of how you want it to be modified, right? So you may say something like, give me 30 variations of racing stripes on this helmet, right? So it'll generate on that photo you created uh, a big number of racing stripes, all colorful. And so now you've got still images of some very interesting kind of very quickly done uh, content. So then you would download the ones that you like, and then within many different types of video mapping, editing software, or projection mapping software, you can put these images in a row and create kind of a one image to the next morph. So you've created a video loop. So that video, and then you also kind of clear out any content outside the actual helmet. So once you've done that, you've got a video loop that you can project onto the object. And then it's just a matter of creating the 3D form and forming the mapping software to the 3D form of the helmet. So you end up with, this is very rudimentary, a cycle of different helmet projections. Okay, so that kind of covered just a high level of some of the ways artificial intelligence is helping, and machine learning is helping for projection mapping and creating content and creating 3D models to kind of simplify that and bring down the costs for the end users and the third-party production and creative companies. Now, we're just in the infant stages right now, but we expect this to really, in the next couple of years, really take off. So I'm going to touch on a few items that Epson does that also kind of help onto this multi-projection mapping storyline. So one thing Epson has is called the Pixeline Camera, and this is a camera that attaches to our ultra short throw lens or directly to the front of our projectors. All of our interchangeable lens projectors and our PowerLight L series will work with this camera. So the camera just attaches, doesn't need any angle of view uh, settings. It's just ready to go. It's connected to the back of the projector via USB, and it gives you access to a lot of powerful tools, which are very helpful in terms of multi-projector use. So, for example, in a projection mapping environment, or maybe not, maybe sometimes it's just for multi-projector use in a presentation type environment. So, you've got access to color calibration. Screen matching is a great tool to make sure all the projectors in the space have the same brightness and color tone. Stacking assist, where you can use multiple projectors to create one large image on the same screen. Edge blending. Edge blending is very important for all projection mapping applications or creating super wide screens. That's where you overlap slightly multiple projectors to create a smooth blend, create a super wide image, or when your architectural projection or any other kind of object projection typically uses more than one projector. And the cool thing is that many of these applications for the camera don't even need an attached router or laptop. You can just run it using the on-screen display. But we do have a free to download tool that allows you to do more with the camera. So screen matching we touched on, highly useful, and edge blending assist also very helpful in terms of creating that blend area you can see here between the yellow and red fish. Okay, so beyond that tool, the camera helps with blending and stacking and screen matching is lenses. So a lot of the sample images I showed you earlier, you can see that the audience is getting really up close, right? You're in a museum, there's an exhibition, you go into a large immersive art space. People are going to get up close to the images. And some of these installations also have interactivity. So people are actually reaching out and touching the surface. So that brings a lot of critical things, requirements for the projector. And one thing is obviously you want to minimize shadows as much as possible. And so one of Epson's lenses, which is particularly popular for immersive spaces, is the ultra short throw lens. And the reason for that is twofold. One, it has, well, one, obviously it can get very close for mounting to the screen. So if you have a low ceiling, you don't have much space, that's a benefit. And the other, obviously, is the fact that it has, you can see the picture on the right, a very sharp angle of view. So very helpful in terms of what I spoke about earlier, minimizing shadows as much as possible and really useful for interactive use cases. And the design as well is interesting because the light starts right where the lens is. So if you have a low ceiling, you'll still get a floor to ceiling projected image. And only the lens needs to peek out. So we've seen at many customer sites, innovative ways to hide the entire projector up in a false ceiling. So you can see a couple of examples here with the photos. The other key need for projection is high resolution when you have up close viewing. And so with the audience getting close to the projected surface, and if that projected surface is really large, if you don't have enough resolution, you're going to see each individual pixel. So the higher the resolution of the projector, the better it is for a more immersive experience. So we've released our new 4K projectors called the EBPQ series, and these have a really stunning 4K resolution on screen. We have a new technology we call 4K crystal motion, and that includes a newly developed Epson developed shifting mechanism that's extremely precise to ensure all those pixels are on the screen in a very sharp manner. And also the lineup is very wide. So we have everything from the smaller ones from 8 and 10K lumens, and the larger ones 13, 16, and 20. So they're useful for areas where you have complete light control, or other areas where you have larger screens need more brightness. And they're also extremely compact. The 10,000 lumen projector is the world's smallest and lightest, and the 20,000 lumen projector is the world's smallest and lightest at that lumen band. So we've been really excited to have these out in the market, and they've been shipping since early in the year. So image quality is a big thing. Color and image quality. All our projectors are 3-chip, 3 LCD, so you get full-time color. The RGB is always on the screen all the time. And resolution, we talked about, super important. And we have beyond WXGA resolution all our projectors, with our main line from 6 to 30,000 lumens giving double HD video resolution, and of course the 4K projectors that I touched on earlier. All right, so I think that covers it all.